In this section, we're going to start breaking down scaling BGP in the service provider network. Now, one of the things that we're going to talk about in our introductory section for BGP in the service provider network is taking what we already know from the route course. So we talked about, what BGP is and what its job is to do and stuff like that. Well, one of the things you should have realized inside of the route course, and if you've taken the route exam, or if you're about to take the route exam, is it focuses more of the infrastructure specifics. How do you form a peering? What are some of the capabilities that you have to offer? And then how do you choose the best path? And what are some of the ways that you can maybe use some, I don't want to say advanced features, so to speak, but more of the like tagging and AS path lists and things like that that are more um, fine-grained, granular filtering capabilities that are in BGP that you normally wouldn't have the capability of utilizing elsewhere. Well, we're going to take where we left off there, and we're going to bring all of that information and all that knowledge, and we're going to bring that to the next level. So in the advanced route course, we're going to take this to the next level and start digging into, scaling BGP, which is the beginning of this one. Now, scaling BGP has so many different facets to it, we really need to qualify what we mean by scaling BGP. So let's talk about the things that need to be in the service provider to begin with, and then we can start building off of those individual pieces so that we can scale BGP so that it makes sense. Because if you're going to be learning BGP, you're really going to want to learn it from the ground up, right? And if you're going to be learning BGP from the ground up, you're going to want to see it laid on top of, okay, we have a solid foundation already. We've taken a look at BGP from the perspective of we've got the core fundamentals down. You know how to peer, you know how to do some basic path selection, and you know some of the techniques to filter traffic and things like that. Those are all wonderful things to know. We're going to take that to the next level because of the fact that BGP is extremely resilient and extremely scalable. There's a definite need for people to understand, how you can build off of that. So one of the first things we're going to take a look at here is IGP routing inside of the service provider. Now you might think IGP, why is that really a necessity? You know, how does that come into play? Well, it really, really is important. It's not going to be one of those things where you don't have to worry about it because the fact of it's just IGP, who cares? Well, if you understand BGP to any real depth, you'll realize, like I did early on, that BGP technically isn't a routing protocol. And you've heard me and some other instructors out there say this. And if one of the things that you really need to understand is BGP is just a path information forwarding protocol. That's basically what it is. It takes information and it passes it on. That's really what BGP's job is to do. And it does it very, very well. As a matter of fact, internet scale well. So in order for all of that to work, there needs to be a core infrastructure in place. And that's what we're going to start focusing on right here. So when you're dealing with the service provider, the first thing that we're definitely going to want to make sure is we're running BGP or static routing with the customer. You can run either or. Now, you don't have to run BGP, but since we're in a BGP course, or the BGP section of the advanced route course, well, obviously, that's the most common way I can see it being done. As a matter of fact, I've only heard of a handful of providers doing an IGP connection with the provider or with the customer, like OSPF or EIGRP. I have seen situations where that comes into play, but they are generally not the way that's done. The de facto standard, the industry standard that doesn't that most ISPs and most customers will follow as a common standard is BGP. I mean, it's just the way it is. So we're going to exchange routes with the upstream service provider via BGP. So from the customer to the provider to the upstream providers. So is the provider you're peering with a tier 3 provider, a tier 2 provider, or a tier 1 provider? Depending on the type of provider you're peering with and what options you choose to peer with them with, that doesn't those attributes alone don't dictate how you're going to be connecting or how you're going to be learning. What does dictate that is the size of the provider. Are you dealing with a tier 1 provider that has connectivity from where you are to wherever you need to go? That's really what that comes into play. So for instance, AT&T, Comcast, level 3. Those are tier 1 providers. Now, you might say, well, what's a tier 1 provider? So let's draw that out for a second and talk about that. Tier 1 provider. And I'm going to go into a lot more detail on how this goes as we progress through here because it's important to understand this. A tier 1 provider is going to have, let's say, for instance, this box here on our screen is the US, right? Down here we have Florida. Up here we have Maine. Up here we have, well, let's say we have Washington. And then down here we have, say, I think California goes all the way down there. Let's say we've got we'll say California down here. Well, if you have a connections, let's say for instance you are, abc.com and you want to connect your Washington office to the Florida office. Well, if you can go out to say whoever ISP and you tell them you need to have reachability from Washington to Florida, let's say you go from Seattle to Orlando or Seattle to, Miami. Really doesn't make much of a difference what city, as long as that provider you can go to them, you buy the circuit, whether it's MPLS, whether it's, just pure internet, maybe you're doing some sort of layer 2 circuit or something like that, like an Atom or VPLS. How you're doing that is really arbitrary. If you connect to AT&T and you find out that you're going to be dealing with AT&T in these first two and in this back half right here in green, this last mile is we'll say this over here is Quest. I'm not even sure if Quest is still in business. And this one over here, we'll say this guy here is Time Warner. If this is the case, let's say if AT&T here is in the middle, what does that tell you and I? Well, it tells you AT&T is not a tier 1 carrier in that particular regard. Now, that doesn't mean AT&T is not a tier 1 carrier. What that means is the locations that you're dropping your circuits off in, your attachment circuit, we'll talk a lot about that in more detail when we get into the edge course. It'll make a lot more sense. But basically, this is the connection that comes into your location and that you connect up to the local point of presence, the POP. The POP is what actually gets you off to the rest of the internet. Well, if AT&T doesn't happen to have circuits physically in that area, they may have to play with or hand off traffic to another provider. Well, this guy could be a tier 2 carrier. If you don't have the situation where you are going, AT&T terminates at both locations, then it is a tier 1 carrier. That means the circuit is end to end. They own everything. They own all the equipment, all the fiber lines, the DWDM or whatever they use in order to get traffic from Seattle to Orlando. If that's all them, great. That covers that. The main thing you want to understand is it doesn't really make much of a difference if AT&T is a true tier 1 carrier or not. They are a tier 1 carrier. I mean, let's not sit there and split hairs on that. They are a tier 1 carrier. So is Level 3, so is British Telecom, so is Hurricane Electric, so is Comcast. What dictates how large of a tier 1 carrier is how often they have to do handoffs to other customers, to other providers, in order to get your traffic from wherever you are to whatever site you're trying to reach. How much of that they have to do will determine how good they are to you, and that's a customer specific thing. I can't dictate that. I can't dictate your opinion on that. I can just kind of feel things out for you. A great example is a customer that I used to work with on a regular basis. They bought AT&T fiber from AT&T, and they had a 50 meg pipe coming into their equipment, and all was well. The thing is AT&T didn't actually have any circuits in this particular area that I was working in. Well, okay, fine. So we ended up using Frontier as the last mile carrier between the physical location that this equipment was terminated in, and then a couple miles up the road where the point of presence was for Frontier. And then from there, it did a fiber backhaul to a city not too far away, and that's where AT&T had circuits in it. So basically, there was a circuit handoff, if you will, from AT&T to Frontier, and then Frontier ran the cable into the building. So if there was ever last mile issues, Frontier got the call. If there was ever AT&T problems, it could have been maybe a DS3, a 40-foot, well, it would have had to be bigger than that. Maybe you had some sort of larger, OC3 or OC192, or maybe some sort of larger pipe north of your circuits that are having an issue. Situations like that do occur, and normally if I'm having a problem locally and I call into AT&T and say, hey, I've got the circuit issue, they'll be able to terminate it down to a certain point, and once they hand off to the third-party LEC, the local exchange carrier, if that comes into play, then you need to take a look at that from the perspective of Frontier. Is Frontier having any issues? If they are, that might be it. Frontier, in my experience, is more of a tier 2 carrier. They don't own their own infrastructure throughout the entire US. They have to, if they want to get circuits from customer A, site 1 to customer A, site 2, and they're in from California to Maine, well, if they don't have end-to-end physical ownership of those circuits, then they might have to pass off to like Time Warner or Comcast or something like that. Situations like that do occur, and they need to be figured out as you're going forward. That's really what it comes down to with how you peer via BGP. That all stems from this bullet point right here. How are you handing off your routes? Now, I'm keeping our BGP table as we progress through here very, very small until we get a little further along. Once we get route reflectors and confederations in place and we start talking about optimizing BGP for how fast you can recalculate your after a failure and edge connectivity and then securing it, we'll take a look at how you would connect and then how do you grow the network. How do you add a bunch of routes? How do you get the BGP table to show up having more than 10 routes in it? Because obviously there's like a 500,000. The last time I checked, there's like 530,000 routes. The last time I checked. IPv6 is quickly growing as well. So all this right here, depending on the situation, can all stem back to bullet point number 2 here. Exchanging your routes and how you exchange your routes is dictated by how your tier 1 carrier, your tier 2 carrier, or if you're beneficial, or if it happens to work out to be in your favor, a tier 1 carrier end to end. Does that happen? Absolutely. I've got circuits here in Milwaukee that I work with on a regular basis that terminate in Chicago, and I'm doing layer 2 replication over a layer 2 circuit. So I have database servers that replicate down to data centers in Chicago so that I have high availability. If I need to fail over my data center here in Milwaukee over to Chicago, all I got to do is change a couple BGP routes, and voila, I'm routing everything towards Chicago now. So is it hard to do that? No, not at all. That's more of the customer end side of the house, but it's how you get that flexibility to come into play, and you'll find that F5 and the global traffic manager or the what is that? The DN is it GTM? I think it's GTM. They may have renamed that. It's the DNS aspect of it where you can change your DNS and the prefix that you associate the DNS and a particular name. You can rotate that over so the traffic flows a certain path. Very cool stuff. That's all. If you ever talk to me out of here, you'll realize that I'm a huge F5 fan. But anyway, back to my original point. With BGP scaling, it's important for you to understand how the individual connections come up. That is why here in our topology here, let me go ahead and clear off our screen real quick. That is why I have both here. If we take this carrier, we have tier 3 carriers, we have tier 2 carriers, and we have tier 1 carriers. Why do we have such a wide variety of carriers? Well, their reach. This big block here, this guy could be, 40 out of 50 states in the US. These guys could be, some other, third-party carrier, tier 3 carrier that only has locations in the Southwest, or in this case right here, could be the Northwest. This guy could be the Northeast. This guy could be the Southwest and Southeast, etc. How that dictates and how that works depends on the size of the carrier. So a lot of this stuff will come into play. It'll make a lot more sense when we get into like inter-AS VPN and stuff like that in the Edge course, where we're going to talk about how do you get reachability from one connection to another. There's a lot of things that come into play with that. But that's out of scope for right now. But I wanted just to give you guys an idea of how that could stretch. The tier 1 carrier is going to provide connectivity between a tier 3 and a tier 2 carrier. And the reason for that is just it's physical reach in the network at the end of the day. That's what it really breaks down to. So our next bullet point here is full mesh iBGP between its own BGP routers, unless you have MPLS, route reflection, or BGP confederations used. Now let's talk about that for a moment. I have MPLS in there. MPLS technically is a viable option, and you can run that. All that does is it swaps and no pun intended here to any label bindings here. What that basically breaks down is instead of routing via IP in the core, you're switching based off of MPLS label. Now, is that a viable solution? Absolutely. How do you think MPLS L3 VPN and L2 VPN come alive? It's MPLS in the core. So you're able to encapsulate stuff inside of MPLS, and that's your experimental bits, that's any of your additional information that you might want to throw in there, the bottom of the stack bit, etc. Not really going to get into an MPLS breakdown right here, right now, but that's one of the things where if you have been working with a service provider for a while, you should have a decent understanding. Now let's park on the MPLS for a moment. Is MPLS only used in service providers? Traditionally, yes. Is it strictly only available for service providers? No. I do work with customers on a semi-regular basis that run MPLS in their core. It is possible, it is done. There's actually a lot you can do with MPLS that most customers, most enterprise customers that I work with don't take on, don't leverage. Why? They have their reasons. I won't even begin to get into them with anybody. But what really needs to be understood here is full mesh. I want you to go back to this original middle bullet point here. Let's talk about that full mesh. Full mesh is needed for what reason? Why is full mesh needed in a network? Reachability, right? Well, if I have a situation where I've got a router here, a router here, router here, router here, router here, router here. It doesn't matter what kind of router they are or what protocol they're running. What matters is you have a router up here and a router up here. I want to be able to connect all these guys together. Is this possible? I want to connect router 1 to router 2. Is that possible? Absolutely. I'm running BGP here and I'm running BGP here. Do I have to run BGP here in the middle? Technically, no, I don't. How do I get around that? Well, you could tunnel the traffic over GRE. That is possible. I could connect R1 to R2 via DMVPN. That's a possibility. As long as R1 can reach R2 somehow, it's a possibility. Now, I'm going to bring all those whiz-bang wow features back down to reality. What you're normally going to want to do is you're going to want to run IGP here and IGP here in between, say, edge 1 and edge 2. If that's the case right there, if we run it that way, then I can simply run full mesh BGP here, so we connect everybody. That's only 6 routers though. What if I have 5,000 routers? Do you still really want to do a full mesh? Likely no. That's when route reflectors and confederations come into play. If I have a situation like that, I want to make sure that I understand thoroughly what's going on. So I can sit there and run route reflectors to where I peer via this guy here to everybody. Does that scale? Absolutely. All I have to do is have a couple of route reflectors in the network, and I'm only peering every router or every other router to the route reflectors. The route reflectors peer to each other, and everybody's happy. So that's just one way of handling that. Now, again, it's a matter of perspective when you're doing that. So I threw MPLS in there just because the fact that it is a possibility to run. Now, runs one instance of IGP, and typically you're only going to use your IGP to propagate traffic between the rest of the edge devices and in the core. So the PE routers use eBGP or static routing with the CE routers. So this is going to be the customer side of the house, right? PE and P routers use full mesh IBGP. When we get out of the advanced route course and we jump into the core and edge, where we're going to be focusing mostly on MPLS, that's going to be an aspect that we're going to be moving away from BGP in the core and putting BGP just at the edge. They commonly refer to that as a BGP-free core, simply meaning that I am not running BGP in the core anymore. I'm running BGP only on the edge, and all BGP is used for is utilizing multi-protocol BGP extensions. So I can run L3 VPN, I can run L2 VPN, I can run multicast VPN. That might be using multicast LTP. That could be running multicast MDT trees. That could be the data tree. It really depends on how you're trying to move forward. IPv6, 6PE, 6VPE. There's multiple different capabilities that come into play. Because BGP is so extensible, it's still a viable option on the edge. And really, you need to have BGP on the edge in order for a lot of those advanced MPLS features to work. Why is that? Well, because a lot of those advanced MPLS features, the route target, the route distinguisher, the cost community, the community values, those are all community values. They're all values that are injected into the multi-protocol BGP updates and sent across the core. And the core itself doesn't know about anything that the customer is doing. The core is basically a transparent layer 3 interconnection device. And all it's doing is providing MPLS forwarding capabilities in the core. So you label switch in the core to the edge and everybody's happy. Now we'll talk about that in a lot more detail. I'm trying to build your understanding up to MPLS. By the time we get there, you won't be brand new, like, first day of school, you walk in, you don't know who your teacher is. You're going to walk in, you're going to be like, oh, I've heard these terms before, I've followed along, and I understand that MPLS is viable here and there, and you'll have just a real high level general understanding. And you'll understand that from a design perspective, you'll be able to move BGP out of the core and onto the edge, and things will still function the way they need to. As a matter of fact, if you go back to the SPRoute course in the BGP section, as I was scaling it out, about halfway through the BGP course, I went through there and I was bringing things back up. Actually, I had a server that I run a bunch of VMs on, had a power issue. Power went out, came back on, I had to reboot everything. Well, in the process of doing that, I purposely misconfigured a couple routers to where only the edge devices had BGP on them. Well, we had MPLS in the core, and traffic was still reaching from, customer A site 1 to customer A site 2. Well, the problem that I had was you'd sit there and you'd see the bunch of asterisk timeouts in the trace route. Well, once I went in there and I made the tier 1 carrier a full mesh BGP peering, all of a sudden our reachability came right back. The reason for that is because I broke the BGP full mesh rule, because I didn't have route reflectors. I had to do that though because of the fact that route reflectors weren't brought up until advanced route, which in the next section we'll talk about in a lot of detail. We'll break how that stuff works and why you would need route reflection. The core IGP is a single instance of OSPF or ISIS and is used only within the service provider core network. Why? Why is this needed? Well, how am I going to get traffic from PE1 through P2 to PE3? Well, I need some sort of IGP in order to propagate that information. Because remember, inside of the provider core, I need some way to provide BGP a next hop to get me from where I'm at to where I need to go. Because by default, if you are not dealing with BGP correctly, you will break the connectivity.